Hello everyone, and welcome to Richard and Dillon's training video for locality improvements. In this video, we're going to show why locality improvement techniques are so important to the programming world. Locality improvement is one way of creating a more cache-friendly code by reordering the way addresses are accessed. Locality improvement techniques have the ability to dramatically increase runtime rates by decreasing cache miss rates. Here's an example of a simple IJK matrix multiply program in C. The reason we are using this is because matrix multiply programs are a good way to test spatial and temporal locality accesses based on how fast the program runs. Using the code from the previous slide, we executed the matrix multiply program 5 separate times, and then we recorded the median to give a baseline for the times. As you can see, the runtime took about 3.7 seconds each time, with a median of just under 3.7 seconds. Compiler flags are a good way of improving the performance of a program. The compiler flags basically optimize the code as it is being translated from the user language to the assembly language. In this case, we used the GCC compiler and tested it out with the O, OS, OG, and the O3 flag. And then we compared it to the code compiled with no flags. As you can see by the graph, the O3 and OS flags dramatically increased performance. Keep in mind, this is on a logarithmic scale, and so the performance was actually 100 times better using these flags. There are many different locality improvement techniques, so we wanted to give you an idea of what a few of them look like in the graph on the left. This graph again is on a logarithmic scale, so it's difficult to see exactly what's going on. This is why we included the separate graph on the right. As you can see with the flags factored out, the locality improvement techniques make a substantial difference in the execution time of the code as well. Technique 5, which used the JIK pattern, ran almost 33% faster than the original code with the IJK pattern. Keep in mind, these results may vary on machines with different architecture. Here we would like to examine the difference between the original C code and the Technique 5. As you can see, the codes are virtually identical and perform the exact same operations. However, the pattern in which they access the memory dramatically changes the runtime. The original code runs through the loops in IJK order, whereas the new code runs through the loop in the JIK order. This effectively lowers the cache miss rate. On the left, we have a graph showing the median runtimes for both the original code and the improved code using all 4 different flags. In nearly every case, the improved code ran faster. This is demonstrated on the graph on the right, which displays the average runtime for both codes factoring out the flags. Again, you can see that the improved locality accessed of the new code increased performance by nearly 33%. In half speed, watch as the top arrow representing the improved code races against the bottom arrow representing the original code. Even with our code only running through the loops 1,000 times, the difference in runtimes is very noticeable. Just imagine how much slower the original code would have been had we been dealing with larger data sets. Thank you, and we hope you enjoyed locality improvement techniques.